Rewrite the quadratic function in standard form and give the vertex. So standard form of a quadratic looks like f of x equals a times the quantity x minus h squared plus k. And the nice thing about that form is it's very easy to locate the vertex. It's just at the coordinates h and k, so you just read them straight from the formula. The only thing that's tricky is there's a negative in front of the h, so you have to take care to take the opposite of that value. To get the quadratic in that form, what we have to do is use a process of completing the square. This process, what we do is we separate everything with an x away from the constant term. Then, if there happens to be anything multiplying my x squared, I need to factor that out. So that would leave me with 3 times x squared minus 2x, and then I have a plus 6 on the outside. Now, to complete the square, I take the number multiplying x, divide it by 2, and square it. So negative 2 divided by 2 is negative 1, and then negative 1 squared is positive 1. But I have to keep everything balanced. I can't just add 1 here without doing something equivalent on the outside of these parentheses. The tricky thing is, most students want to then just subtract 1 on the outside. But the 3, because of the distributive property, it actually multiplies everything inside of these parentheses, including the positive 1. So adding 1 here actually means I'm adding 3 to this side of the equation. So in order to balance that out, I have to subtract 3 on the outside. And now we're pretty much done. The perfect square trinomial here factors very easily. You can go through the factoring process, but it's always going to be x plus half of this number, so half of negative 2 is negative 1. Then it's a quantity squared. And 6 minus 3 is 3. So we have the vertex then easily located at the opposite of this number, so positive 1, and this value,